In this video, you will learn how the function notation works and what it means. At the same time, you will learn the words like domain, codomain, range, image, and object. I will teach you how to represent a function in 3 different ways, and knowing what's the difference between the discrete function and a continuous functions, the type of relations of a functions, and last but not least, you will go home with knowing how to check whether a function is valid or invalid. So without further ado, let's begin with what's the meaning of functions. For me, function is a 3 steps process. First, it's going to take an input from you and then process the input with the instructions, and bam, here is the output for you. You can imagine like you go to a restaurant like a Pizza Hut. There are a bunch of ingredients for you to choose. Once you tell us about your choice, we will process the pizza and serve you with the pizza that you have chosen. Same goes for the juice processor. We don't really know which fruit that you're going to put it in, but once you make a decision, you put inside a juice processor, it will process and serve you with the delicious fruit juice. Whatever that you're going to put it in is what we call as the object. And whatever coming out from the functions after it getting processed is what we call as image. And in a more mathematical way, you can think of like I want to create a functions that will help us to double the money and give it to the next person. I am very bad in mathematics, so I create a function for me to calculate the amount of money after double. First, you need to know how much of money initially. So let's say it's 100 ringgit. So we're going to put inside a functions. It will help us to calculate behind the scene by 100 times 2 and give it back as an image to us. So if 500 it will return us with 1,000, 700 it will tell us is 1,400. Let's introduce you with a more formal functions notations that looks like in the textbook. But it looks very scary and complicated, so we're going to put it aside and go through step by step. Functions first begin with a letter. This letter is eventually the name of the function. It can be any alphabet, it can be A, can be B, can be C. So it just depends on what's the questions or what is your own preference. But most of the times you will see F as the golden standard. Right after the name, we have a parenthesis. Inside the parenthesis, we have the variable. This variable is eventually the input of the functions or what we call as the object. Why is a variable is because we don't really know what is your choice until you tell us. So we will temporarily use a variable to receive the input from you. And then we put the equal sign. Right after the equal sign will be the instructions of the functions. It will tell us how to process your input and make it as the output of the functions. So basically the x is an unknown until you tell us about what is your choice. So for example, if you tell us you choose number 5, then I will replace the x with 5. So now, once we receive the 5, we process it with 2 times 5 plus 5, I'll get 15, and this is the image or the output of your input. Or sometimes you will see the book write down a function with something like this, where they use the colon. So this basically will represent the same meaning with the one on top, just a different way to represent the functions. So now let's try with a bunch of different input and see what's the output. And again, whatever we're going to put inside a function is what we call as object. Whatever coming out is the image. So let's say I'm going to choose a number of 2. Since I chose number 2, means it's now no longer an unknown. So we eventually know the input is 2. So the x, all of the x in the functions or the instructions will replace with 2. So 2 times 2 is 4. So eventually I have 9 as my output or what we call as an image. Let's try again with 5. So if I choose 5, means I know the input is 5 is now no longer an unknown. So I will put it inside the instructions and they will process for me, and in the end I will get 15 as the result or the image or the output of the functions. You can try with 7 and 12 to see whether you will get the same output as mine. So now we're going to learn how to pronounce the functions. The parentheses, we call it as of. So we can say the f of x is equals to 2x plus 5. So if I have g and x, I will pronounce it as the g of x is equal to something. Or you have a of x, so this is how we pronounce it. But if you use colon, we have a different way to pronounce. This colon is what we call as maps, which it means it will connect the object to image. So we can say the function f maps x to 2x plus 5. So now let us try to write it down in more formal way that you will see in your book. So again, we have a 3-step process. First, we want to receive the input from you. So if I choose 2, then I will go to function f and say the input is 2. So what happened behind the scene is they will follow the instructions by substituting the x with 2, which is based on your input or your requirement. And then they will give it back to you as 9. Same goes to 5, 7, and 12. So any difference with the one on the right is no difference, but just a different way of writing it down. And just as a reminder again, whatever the input is eventually what we know as the object, and the result is our image. So let's go through a bunch of questions that you will see very often in the exam or any homeworks. So first, find the image of 1. You can think of that object and image are always together because 1 is input, 1 is output. So when they say find the image of 1, basically 1 means the object. Because if this is the image, then the one behind it must be the object. So now we know this function will receive the object as 1. 1 is chosen. So no longer an unknown, all of the x will change with 1. So 2 times 1 plus 5, and this is how we get the answer as 7. 7 is the image. Next, find the object of 11. Since they are asking for object, means the one behind it must be the friend or the brother of it, which is our image. So it means the answer is eventually 11. So we can say the answer of this function is eventually 11. But what's our function? Our function 2x plus 5 is 11. So what we're going to do next is just a very simple algebra, and this is how we get our x is eventually 3. So what happened here is now, whenever they ask for object, means the one behind it is the image. If they ask for image, the one behind it must be the object. And next, they're asking for what is the value when we have f of 10. Sometimes we have a multiple functions given in a question. It can have a gx or hash of x. So what we're going to do is we go to the function f, and this function is going to receive the input of 10. So all the x will now replace with 10 because we have received the order from you. So we can say f of 10 is equals to 2 times 10 plus 5, which is going to be 25. Or you can see the question like, find x when f of x is 55. So what we're going to do is, we write it down first as whatever is given, but we know the instruction of f of x is actually 2x plus 5. So we write down 2x plus 5 on our left, and we're going to solve the algebra like whatever you have did in your previous questions. And last, we have the answer of find the x when the value is negative 9. Whenever they say the value, they are referring to the answer or what we call as the image. So in other words, it just means that, hey, find me what is x when f of x is equals to negative 9. This is very important and we see it very often. So the value is eventually the answer or the image. So just like just now, the f of x we know is 2x plus 5. So we solve the simple algebra. This is how we get x is equals to -7. And this one more question is very often seen in the exam is, find x when the function map onto itself. When they say the function map onto itself, it means whatever you put in the object, let's say I choose a number of 2 as the object, they will return me 2 as the image. It means whatever we put in at the object, they will return as the image. No matter what you put it in, it will get back whatever that you want. This is what we call as the function map onto itself, where coincidentally, whatever you're giving in, it will just give you back as the same answer. You can think of like, if the object is 2, they give you back to you as 2. If 5, it gives you back to you 5. And if your object is 10, they will give you back to you as 10. So for these questions, what we're going to do is we say, when we put in x as the input, they give it back to us x as the answer. This is what we should do whenever they say map onto itself, since we don't know what's the number they're going to give us the same answer. So f of x again is our 2x plus 5 must be same as x. So we solve the algebra where we move the variable on the left and we move the number to the right. And then we have the answer as x equals to -5. Just for a verification, we try to put -5 as our input. So we try to process it and see whether indeed the image is the same. So we have -10 plus 5, and yes, indeed we have the answer as -5, which is the object is same as the image. This is what happens when we say the function map onto itself. So this is only one of the functions that we learned so far. So eventually again, we say the first letter is just the name of the functions. So don't be surprised if you see like G or H or K. This is just a name where they say it will receive the input as A. Means A is the unknown that we not yet know what you're going to choose. So let's say if I choose 2, means all of the A will now become 2 and give me the image of 3. Or sometimes we see something like H. H is just a function name that will receive the unknown of K. Once they know what is K, they will replace the K with a number that you chose. So let's say if I choose 2, then all the K will become 2. So it become 2 square plus 2 times 2, which is 8. So don't be surprised if you see a different letters in your textbook or in your questions. But again, the input is always known as the object and the output is always known as the image. So next, we're going to learn how to represent our function in arrow diagram. Arrow diagram is represent like a set. So what we're going to have is we have a shape, either it's a circle, rectangle, whatever shape that you like. So whatever on our left, most of the time is our domain, or what we call as a bunch of choices that's available for you to choose. Or for me, I think of this as a restaurant menu. When we go to a restaurant, they have a menu for you to choose what kind of dishes that you want. So for this case, we can have the input of 2, 5, 7, or 12. And on our right hand side is our codomain. Codomain is like the possible outcome after the processing. Means what is the possible result of these functions is what we call as a codomain. So the function eventually will maps whatever on our left to the result. Like if you choose 2 as the input, they have 9 as a result. If you choose 5, you have the 15 as a result. So this will clearly show us the relations between the object and the image. So on our left is the input, so we can say this is X because we don't really know which one you're going to choose. And once you choose this one, we're going to process it with the function f. And how we process it is by following the instruction of 2x plus 5. And as a result, you will get the answer on your right. So basically the arrow is a functions. On our left is the object. On our right is the image. So every individual one is object. So we have 2, 5, 7, and 12 are the objects in the domain. So 9, 15, 19, 29 are the images. So those are the image. Those numbers that have the partner with the objects means they are connected with the object is what we call as range. And whatever is not connected is what we call as not in our range. So they are inside the codomain but not inside our range of these functions. So now we're going to learn how to write down the answer for domain, codomain, range, image, object, and whether it's a function or not. Domain, codomain, and range is something new that we're going to learn in this year. So we're going to use braces because they are eventually represented in a set. So once we have the braces, we're going to look at domain. Domain most of the time is on our left. It's like, what are the available choices for us? So we have 2, 5, 7, and 12. So we write down in the braces. Same go for the codomain. Codomain is whatever the possible outcome, regardless of whether we eventually have the object going into the numbers or not. So we have 9, 15, 19, 29, and 45. So most of the time, the student will left out the 45. Remember, codomain is all of the possible result. So we include whatever is inside the list. And range is whatever that have the partner. Means we have 9, 15, 19, and 29, and this is out of range. So when they say image of 5, again, image and object is like the brother. So if they say image, means the one at the back is the object. So if we go to object 5 and look for it, and the image is eventually 15. When they ask for object, then we know the one at the back must be the image. So we look for the image 19 and reverse to see the brother of it, which is the object, is eventually 7. So is this a function? Yes. How do we know? If we want to know whether it's a function or not, it's like if we put a thing into the machine or the functions, they will always give us back with one answer only, one definite answer. If you can imagine, like if this is a functions, if I ask something and they give us a multiple answers, then I have a hard time to know which one is the accurate answer. So to make sure it really works and it's a functions, each of the object must have only one image. So for this case, yes, this is a functions. But function not only can be represented in arrow diagram, it can be represented in order pair as well. The order pair is a set that consists of the couple in a coordinate form. You can think of like in a coordinate we have x and y, but now is the object and image is make up the coordinate. So the first pair is 2, 9, the second pair is 5, 15, the third pair is 7, 19, and the fourth pair is the 12, 29. It's just that easy, but don't forget, put inside the braces to represent the set, the parentheses represent the couple or the pair of the object and image. And last, we learn how to draw it out in the graph form. The x-axis is our input and the y-axis is our output. So this is the object, this is the image. So sometimes if the function is a g of a, so we know the input is a, so our x-axis is going to be a, and the y-axis is the image, which is a g of a. So it will literally based on what is written down in the questions. So x is the available choices, or we call as the input. So we have 2, 5, 7, and 12. And our output is eventually 9, 15, 19, and 29. And we're going to do it like a coordinate. So we have this, and this. But don't connect the line because this is like one object mapped to one of the image, one by one, but it's not a continuous one. So now we have learned how to represent the function in 3 different ways. And up to now, whatever that we have learned is known as discrete functions, where we have a finite number of the possible values, which we can list it down every single of it. Like just now, we know the available choices is 2, 5, 7, and 12, the possible outcome is 9, 15, 19, and 29, and the one in our range is 9, 15, 19, and 29. So basically that we have only a bunch of the choices and the output. But whenever we have a continuous functions, this is where we have infinite number of possible values where we cannot list it down every single of it. As a result, we will only take the minimum and the maximum of our data. You can think of like if minimum is 0, maximum is 100, means we can take whatever the intermediate value in between the two. It can be 0.01, 0.02, 0.05, so on and so forth. So it's impossible for us to list it down one by one. And the graph of a continuous function will look something like this, where x is the input and f of x is the output, and it's a continuous means every single dot of it is a possible value, which might consist of 1 million. If I break it down to be 1 million pieces, it can be 1 billion if you want to break it down to be 1 billion pieces. So for this one is a function of a square root of x. So what we're going to write down the domain is, we can just say that, hey, this function can receive whatever traces from 0. Maybe I want to limit it to 100. So you can say it can take the possible choices from 0 to 100. So I can write down as a 0 to 100 because it means we can take it like 0.01, 0.02 and endless amount of the possibility as long as it's between 0 to 100. So sometimes you can write down in a more formal way that we say domain is a set where x is the member in the set, but to be the member of the set, it must be in between 0 to 100. So this is how you write in a more formal way, but most of the time, this will be fine as well. But if you want to learn this one, you can break it down one by one. You can think of like, this is the set. And the member in the set is what we use x to represent. But to be the member of this set, you must be in between 0 to 100. So this is the member, and the one after the colon is the requirement to be in the set. How about the range? So the range or the codomain, so since we have the biggest number is 100, so square root 100 is 10. So we know the highest number that we get is 10, the lowest is 0 because the square root of 0 is 0. So the range must be in between 0 to 10. So again, if you want to write down in the set, we can say range is a set, and this set is range consists of the value of the image, where the image must be in between 0 to 10 only. So this is how we write down in the notations. So now we know that's the difference between discrete and continuous. Discrete only have a handful of choices and a handful of the image, where continuous means they will continuous and they will eventually have an infinite amount of possibility, where we can only use a minimum and maximum to simplify our writing. And last, we're going to learn the whether a function is valid or invalid. So in order to be a function, each of the object must have only one image. So for example, the one on our left is our domain, or we call it as the individual element is the object. So we check each of the object indeed has only one image. So this is a valid function. How about this? So you can check from left, from the first one, so each of them indeed also have only one image. Although this has one extra possible outcome that has no partner, but it does not matter because the definition saying that each of the object must have only one image. How about this? With one extra choices, but it does not have any image. But that's the problem. The rule saying that each of the object must have only one image. So if you have zero image means this is not valid anymore because this object does not have any image. So you can have extra in the codomain, but you cannot have the extra in the domain. In fact, these two functions is what we call as a one-to-one functions. But the difference is, this one use up all the possible outcome. So when you use up everything, we say you turn on everybody. So this is on to functions. But this one, we have more possible outcome, means we only use 3 out of 4, means we have one more extra, means you don't really use up everything. We say this is into functions. Let's try with more examples. So let's say the one on the left first. So again, to check whether it's a function or not, I will do one by one to check. So this has only one image, this one image, this one also one image, this also one image. So it's good. So this is a valid functions. But the difference between this and the one just now we do is multiple objects have the same image. So we call this as a many to one. I read it from left to right. Many objects go towards the same one image. We call it as a many to one functions. For this one, we check again from the number 1, but this is not good because why? You see, one object has 2 images. It has number 1 and number 2. So 2 images, not a valid functions because one of the object has 2 images. So this is eventually a function of one to many functions. And next, we're going to check this one. So this one has only one image is good. This one has only one image is good. But this one, you can see, it goes to 2 images. So this is not good. So this is the problem. So this is going to be not a valid functions because one of the object has 2 images. But what kind of function is this? What's the relation of the function? So the first two, like many to one, right? This is like many objects go to one image. But then this is eventually one object go to many images. So it's one to many. Whenever we have many to one and one to many exist is in one functions, we call this as many to many functions. But this method is going to be very useful in a discrete functions. How about a continuous functions? How do we check whether it's valid or invalid? We're going to introduce you with a vertical line test. So basically it means if a vertical line touch only one point of the graph, then it's going to be a valid functions. If the vertical line touch more than one point, it can be 2, can be 3, can be 4, means more than 1, then you are not going to be a valid functions. So most of the times, when we use a ruler, we're going to sliding it from left to right to screen it or scan it. So you can see, it never touch more than 1 point. It only touch exactly 1 point. So this is why we say this is a valid functions because the vertical line only intersect with the graph at only 1 point. But if we test it on the one on the right, if I sliding it from left to right, you can see, bam, we hit 2 intersection point. You try to move again, we touch more than 1 point. So this is a not good sign. So this is not a valid function because the vertical line intersect the graph at more than 1 point. Hey, if you want to join my online tuition class, please drop me a message on Telegrams. Or if you want to support us so that we can make more videos like this, the simplest way is just to sharing the video with your friends. Hit the like buttons and consider subscribe to this channel. See you in the next video.